G'day and welcome back to part 2 of our new Python for Lego Spike Prime series. If you are planning to take your Python robotics skills to the next level, then don't go anywhere. Roll the thing! Hello, I'm Mr. Code, and today we will go through a whole stack of skills for taking your Python robotics to the competition tables for First LEGO League or the World Robotics Olympiad. If you want to learn the bare basics first, then make sure you check out my part 1 video over here. The sponsor of today's video is More Educational, who have kindly provided me with the LEGO Spike Prime kit that we have today. More about them later in this video. Before we get started, make sure that you build this model that we have today. It is called Driving Base 2 and it is in the LEGO Spike software. So if you go into your Spike software, you will find in Spike Prime, go into the build menu, scroll down to Driving Base 2. Now you'll need to build the driving base first, and then you will also need to build the tools and accessories. After that, you will also need to add on the tools for driving base 3. So after you have built driving base 2 tools and accessories, go back out this menu, go down to driving base 3, and then just add the color sensor module over here. Once you finish with the building instructions, you should have a model like this. So this is a driving base with your distance sensor facing forward. You can test the arm in front by spinning the motor below so that it opens and closes like this. And then also there is a touch sensor and a color sensor on the side as well. Now, I spend a lot of time making coding tutorials just like these. So if my video helps you out in any way, then please consider liking and subscribing to my channel. It is your support that lets me continue making coding videos. So I thank you in advance. Today, we're going to start with reading the knowledge base on Spike Prime. So put your model to the side first, and then we are going to check out our software. Here we are going to start a new project called Python. Make sure it's a Python project, and then call it, what were we calling it before? Python 2. Create. All right. So here's our coding area, but on the right-hand side here, our knowledge base tends to take the back seat a little bit when we are doing tutorials. The fact is that the knowledge base should be your friend, and it's going to be very handy if you understand how it works. For example, when we were talking about the distance sensor in the last video, you can scroll down to distance sensor here, and then you can see a whole bunch of sample code here. So here's the sample for importing the distance sensor, setting the distance sensor, defining it, and then also you can see how to make it light up and make different measurements as well. You can also see events here so that the distance sensor triggers different things to happen on your robot. So very, very useful stuff. For example, if I wanted to see how to measure a distance with a distance sensor, then I'll go into measurements and then go get distance centimeters. All right. So the first thing that you'll see up the top here, so this is called a method, like we talked about last lesson. Here's the method name, and then inside here we have the argument. So here short range equals false. That basically means that we can switch this from false to true if we want to activate the short range mode in our distance sensor and measure short ranges better. Down here, you also see all the different errors that can happen, and also all the different parameters and an explanation of how they work. And then finally, the very important part is the code example as well. So these coding examples, you can just copy these and paste these into your code and try running them. Okay, so your knowledge base is your friend. It doesn't take into account how you have built your robot though. So keep that in mind. If your robot is built differently to what it is specifying in the knowledge base, then that can also cause some issues. But as long as you keep that in mind, you should be able to use the knowledge base, no dramas at all. You can look at not just every component, but also these helper functions as well, like timer, for example. For timer, you can see how to reset the timer and how to get the timer now in seconds since the start of the program. Really useful stuff. Definitely get used to using the knowledge base and reading about the different components here. Now that we got the knowledge base out of the way, it is time to learn our next level skills. So our first thing that we're learning about today are motor pairs. Now, last lesson we talked about moving a single motor when we attached a single motor to the hub, but a motor pair is designed specifically for navigation. So it is made for robots just like these, where one motor is controlling one side of the robot and then this other motor is controlling the other side of the robot. As you can see on this robot's design, we have these two wheels side by side. And if both the wheels are traveling at the same speed in the same direction, this whole robot will end up moving straight, right? But if I wanted to turn for navigation, then I just need to change the speed or slow down one side of the robot, and then I'll be able to change the overall direction and also the overall heading of the robot. And that is what motor pairs are for. Now let's get into how motor pairs work. First of all, we need to look at our hub file. So every time I type something here, feel free to type it yourself as well, and also pause the video if I'm typing too quickly. So we are going to define our wheels just like we would define any other motor. But this time, instead of using a motor, we're going to use motor pair. So motor pair. And instead of using just one port, we're going to use 2 ports. So the 2 motor ports, I believe, is C and D. So C is on the left wheel, comma D. D is on the right wheel. So this basically means that we have defined a new object. This is not one motor. It is a motor pair. A motor pair works in concert with each other. So it is very, very important to note this. It is very different. So when we have a look at our knowledge base, we can also see that single motors and motor pairs are separated out. So let's have a look at motor pairs here. And you can see, just like how we have defined our wheels, we are using the same methods to define it. So the first thing we're going to do is test it out. Going to make it so that we can move forward and backwards. So let's go wheels dot move, and then we're going to say move 10. What that does is it defaults to centimeters, and it is going to move 10 centimeters forward. So default is centimeters. So I'm just going to power up my robot, and then we will run this code. Alright, now that we have our robot moving straight, we can make some more adjustments to the parameters to give it a little bit more control. So let's have a look at our move method here. So here we go into our motor pairs in the knowledge base. It's behind me right now. So here we're going to the move method, and then you'll see up the top here that there is a few different readings here. We got the amount, the units in centimeters, the steering, which equals to 0, and speed, which is none. So this means that we can put in up to 4 different arguments into this this movement. So here, let's have a play of that. So I'm just going to comment out our first wheels.move command, and then we're going to go wheels.move, and instead of moving 10 centimeters, let's move 10 inches. So here we go 10, and then comma IN. Okay, so how do I know that IN is a valid value? I go back into knowledge base, and then you can see here when the specified unit is centimeters, cm, or in. See over here, we got centimeters or inches. So I can make it so that instead of moving for 10 centimeters, we move in inches. If I wanted to specify it to be centimeters, I just put cm, right? But if I don't put anything, then it defaults to centimeters. All right, so here I'm going to specify inches and then roll it for 10 inches. Next, I want to see if I can change the direction of my robot. I don't want to just keep moving straight forward each time I'm moving. To turn towards the left or to the right, we need to change our steering value, and that is our third parameter inside the move command. So here, if I go comment that out, we're going to go wheels.move. We'll move 10 inches. But instead of moving straight, if I keep my value at 0, you see here my default value is 0 for steering. So 0 means that I just go straight ahead. It means that there is no difference between the speeds of my two motors. If I make it negative, anything up to negative 100 or down to negative 100, then it will spin to the left. But if it is anything above towards positive 100, then it spins towards the right. So let's make a little bit of an S-curve, okay? So I want to move forward 10 inches, 20 inches. Oh, no, sorry. 20 steering towards the left. And then I'll go wheels.move 10 inches and steer 20 towards the right. Okay, that's pretty straightforward so far, right? So all I have to do to change the speed now is to enter the fourth value. So here, I'm just going to comment that out as well. If I go wheels.move 15 centimeters, and then I want to move directly straight, I can enter a fourth value, anything between negative 100 to positive 100, to change the speed. So negative anything below 0 means that I'll be reversing, whereas anything more than 0 means that I'm going forward. So here, if I go negative 30, that will be negative 30%. So I'll end up moving backwards for 15 centimeters at 30% speed. We can also get more control over each individual wheel by using a start tank or move tank block. This is very similar to your EV3 Mindstorm's tank move program. And what we do is we set the speed for each motor as we move. So let's have a look at how that works. Here we're going to comment this out. And we can use this move tank method. So I just go wheels.move underscore tank. And then I can say to move forward, say 20 centimeters. So 20, comma, cm in quotation marks. And then I can change my left motor speed and my right motor speed so that I have more control over exactly what power, what speed my individual motors are having. So I can make it so that my left motor is going at 50% speed and my right motor is going at 30% speed. And because my left motor is going faster than my right motor, this is going to make it a gentle turn towards the right. So far, all of the movements for our motor pair are set in centimeters or inches, but how does our robot know what our wheel diameter is? Well, the answer is that by default, Spike Prime will assume that you are using these wheels, which have 17.6 centimeters on the circumference, and that is the default value for your circumference for one rotation of the wheel. So to set that to a different circumference, we will use another method. So if you go here into our motor pairs, you can see down here we have set motor rotation. So if you run this command, set motor rotation, and then the amount in centimeters or in inches, then you will be able to change that circumference. For example, if I wanted to change my circumference to be 20 centimeters, then I'll go wheels dot set motor rotation 20 cm. All right. So as long as I run this command before I move, then it will adjust all of the rotations of the motors so that it matches this new setting. However, we can also skip this by changing our amounts to use degrees or rotations instead. So here I can make it so that my wheels move one full rotation, for example. So here I'll go wheels.move 1 and then rotations. So make sure you put an S there, even though it's just one rotation, and that will basically mean that we move the robot one full rotation forward. And so same as before, we can change the steering. So steering 0 means we go straight forward, and we can change the speed as well. So 25 will mean that it's 25% heading straight forward. Finally, for motor pairs, we can also start the motor and make it just continuously move. And if we pair it up with our sensors, then we can make it so that we have a sensor-controlled movement. For example, if I want to move the robot forward until I bump into the touch sensor and then stop the robot, then we can do that with the start and stop movement modes. So here we're going into Spike again. We go here, we say wheels dot start, and then for start there is an argument here as well. So if I go into the knowledge base of start, I can set the steering, so I can set it to just move forward continuously, and the speed I'm going to set it nice and slow at 20%. Wheels dot start. And then I want to make it so that we just move forward until I press the button on my hub. Okay, so the left button on my hub. So to do that, we say wheels.start, and then I'll look in the knowledge base again. I'll go prime hub, or actually I think it's in buttons, and then wait until pressed. So I'm going to press the left button. So here we'll go hub dot left button dot wait until pressed, and then we can make it so that we stop the motor after that. So here, wheels dot stop. Now it's time to make it so that our robot can detect some obstacles. There are two main ways that we can detect obstacles with our robot in its current configuration, okay? We're going to do a simple one and then a slightly harder one. The simple one is that we are going to move forward and then detect if we press our touch or our force sensor in front of the robot. So if it bumps into something in the force sensor, then we are going to stop the robot. And then after that, we're going to use our distance sensor here. So when we detect that something has come close enough to get close to bumping the robot, then we are going to stop before it bumps. Okay, so let's start with the easy one. So let's you can twist the bottom motor so that the arm moves up. That way we can see the force sensor really easily. And here we're going to do something very similar to our previous code. So all we have to do is go wheels.start, and this will make the wheels start spinning. We can also set the speed, make it nice and slow. And then we're going to have to define our distance sensor, just like we did in our first video. So here we go up back to the top. And this is another important thing about coding in Python. When we are coding in Python, we want to keep our code nice and organized. So we always start with our imports and our definitions right at the top. Then we go for our objects that come straight afterwards. And then we define our functions, which we'll talk about another time. And then we do our coding execution. So here is our structure. Right at the top, we have our imports, then followed by our objects, which are the bits and pieces of our robot. So here I'm going to go distance sensor equals distance sensor, and our distance sensor is connected to F. I know it's connected to F without looking at the robot because up the top here we see all of our port connections here. So F has our distance sensor connected to it, and we also want to define our force sensor. So force sensor equals force sensor A. Okay, same thing, we see our force sensor up the top here. Okay, so after we start our wheels moving forward, we're going to wait for our force sensor to get pressed. So we go force sensor dot wait until pressed. Same as our hub left button. And then once it's pressed, we'll go wheels dot stop. Okay, so if it detects that we have pressed something, then we are going to stop. Super easy, right? So our next one is our distance sensor. So I'm going to comment this out as well. So we'll say wheels.start 0, 20, nice and slow. Distance sensor dot wait until distance. Oh, wait until closer than. I think. Hold on for a second. I'll just see our distance sensor. Wait for distance closer than. Wait. Oh, okay, almost got it right. Wait for distance, whoops, closer than. And then here we put in our argument. So here we're going to wait for distance closer than, let's make it 20 centimeters. So 20 centimeters, after we have detected that something is closer than 20 centimeters, then we're going to stop the motor. But make sure before you run to lower the arm for the robot as well, because the way that this robot is designed is that when the arm is lifted up, then it covers up our distance sensor. It's not ideal, but we've got to live with that, right? So let's test out our code. Now you know how to detect obstacles with your robot, whether it is by physically bumping into something using the force sensor or sensing it with your distance sensor. And both of these are really useful for making any kind of navigation robot, because sometimes when you detect an obstacle, you need to change your route, and sometimes it also helps you find targets to fulfill your mission. So really, really good stuff that you have been able to do that so far. The next really important skill is to follow a line with your robot. So you'll notice that on the bottom of our robot, we have a color sensor, and we haven't used the color sensor yet. The color sensor is really helpful because it can shine a light onto a surface and then detect the color that is on that surface. So for a lot of robot competitions, you'll see these black and these white and these multicolored lines going all through the table or all through the map. And you need these color sensors to detect where those lines are. Once you have detected that line, you're going to need to be able to change the direction of your motors so that you keep on following that line. Okay, so let's get started with our color sensor. First, we're going to go here and define it. So color sensor equals color sensor, and put it at B. And let's start with something simple first. Let's make it so that once we've detected a black line, we stop on it. So this is sort of like a sensory move with the distance sensor, where if it detects something in front of it, we stop. But instead of detecting something in front of it, we're detecting below. We're seeing if we've detected a black line, and if we do, then we stop the robot. So let's do that. Wheels.start 0, 20. And then we're going to say color sensor dot, and then we have a look at our color sensor over here. And then we can see here we got wait until color. So we'll say wait until color, and then inside what kind of values can we have? We can have any of these lowercase values. So black, yellow, violet, cyan, blue, green, whatever. So here, wait until the color is black. Because once it's black, go wheels.stop. Okay, so we have successfully detected a line with our color sensor. But now the hard thing, following a line. So when you are imagining this robot traveling on the line, a good way to think about it is that where the color sensor is not actually trying to find the middle of the line. Okay, it is actually trying to find the edge of the line. What do I mean by that? Well, imagine if my color sensor is, my color sensor is right now on the right-hand side of the robot, right? So the line we're trying to keep on the left-hand side of the color sensor. So if my color sensor does not sense the black line, then we can assume that we are too far to the right of the robot of the line, and we need to move towards the left. And when I do see the black line, I'll notice that I don't want to overshoot the line, so I'll turn away back towards the right. So we need to make a combination of code here. So the combination is this: when we detect that we are not on black, then we move to the left. But if we are on black, we move towards the right. And this is called binary line following, because there is two separate cases for which we are moving. one is to the left, one's to the right, and it depends entirely on the color sensor whether it's sensing the color black or not. So to do that, we go here. We're going to make a bit of a loop, but we'll make this loop on time related. Okay, so here we're going to set a timer. So we'll go, whoops, timer equals timer. And then we'll say timer dot reset. And then while timer dot now is less than 3. That means that we are going to continue this while our timer is less than 3 seconds. So we're going to follow the line for 3 seconds, essentially. So here, while timer.now is less than 3, then we're going to do the following. All right. Remember, when the color is not black, we move to the left. Okay, and then else, if color is black, move right. Actually, this might be better if we go and switch these around. Yeah, let's do that. All right, so if the color is black, move to the right. If it's not black, move to the left. So here's the else. Okay, so just like that, we're going to do the code. All right, so if color sensor dot get color equals black, then we'll say wheels dot start. Now this is important because we're not making a move for a fixed distance, right? We're moving based on our sensor, so we don't want to use the move command. We have to use the start command. Start, and then our steering moving towards the right. Okay, so moving towards the right is maybe about 40. Okay, we might have to tweak this later on. And then here we'll say else wheels dot start -40. That means that we're moving towards the right if we sense the color black. Otherwise, we move towards the left. Oh, might want to change this to be nice and slow as well. So change the speed to 30. All right, let's test that out. Well, it went really well for 3 seconds and then it went haywire. And the reason is because I didn't tell it to stop after 3 seconds. So it's my mistake. So here, after we have done our move, we have to stop our wheels. So wheels.stop, open and close command. And also, we can change it now so that we follow the line for, say, 10 seconds. So here, if I just change that, then we'll follow the line for 10 seconds. So the next thing we're going to do is learn how to use the arm, the lifter in front of the robot to manipulate objects. And that's really, really cool because we want to be able to use the arm in front of the robot to maybe trap this block and drag it around and move it to different places. So let's check out how that works. Alright, so just like before, we are going to define our lifter. So go back up to our objects here. So lifter equals motor. So it is a single motor this time. It's actually a single motor. And we are going to define it at E. And this lifter is interesting because we need to find out how to make it move up and down. And if you twist it, you'll notice that if you twist it clockwise, if you're looking up at the motor, you twist it clockwise, it goes up, and if you twist it anti-clockwise, it goes down. So we are going to do a little bit of experimenting here. Make sure you have defined the object for the lifter. If you're skipping over here, make sure that that you've done that. Okay, so here we go. Lifter dot run for seconds. So what does run for seconds do? Run for seconds spins the motor for an amount of time, right? So if I go for the single motors, run for seconds, I can set the amount of seconds and then also the speed. So here, if I go spin it for 1 second at a speed of 50, that's positive. So a positive number will spin the motor clockwise, and that's going to open my my lifter. Okay, and then what I can do is I can move forward a bit. So we go wheels dot move 20 centimeters. And then I can close the lifter. So lifter dot run for seconds, 1 at minus 50. And then I can move my wheels back. So wheels dot move 20 at 0 steering at negative. Oh, hold on. It's centimeters. 0 steering and negative 50 speed. So that's going to make it so that I can move forward. I'll open up the lifter, move forward, close the lifter, and then move back. And then hopefully it's going to help me retrieve my block. I want to thank the sponsor of today's video, More Educational. Ever since Creator Academy started making LEGO education videos, we have been greatly supported by the experts at More Educational. They are an authorized partner of LEGO Education with over 20 years experience working with LEGO education products. So if you're in Australia and you want to buy genuine LEGO education products like the ones shown in this video, then make sure you check out the More Educational website. That's it for us in part 2 of our video. Next time, we're going to learn some even more advanced Python skills. We're going to learn how to do multiple things at the same time. We're also going to learn how to use our gyro sensor to turn accurately and how to use lists and functions in our code. That's from me today. I hope you found the tutorial today useful. If you have a question or comment, then make sure you leave it in the comment section below. I'll see you next time. Bye bye.